And section 6.3 is the last chapter, or last section we'll do in chapter 3. And there's really only 2 new things in section 3. That kind of makes it nice. And before I go into anything new, I'm going to start with a quick little review for you. Right here. And this is going to go back to 6.2. And if you remember back in 6.2, we had 4 theorems. They all started the same way. We said if a figure is a parallelogram, then 4 things happen. And we'll give you a shot here, see if we can fall for it. Anybody remember one of them? If it's a parallelogram, something you know about the parallelogram? Yep.
Choose the congruent sides.
Yes, both sets of opposite sides are congruent. And all of these have a theorem number. I don't remember what the theorem numbers are. If you remember the words to it, that will work just as well as the theorem numbers. All right, so if it's a parallelogram, the opposite sides will be congruent. That's one of them. There's 3 others. Anybody think of one?
There's 4 sides.
It is going to have 4 sides. It's quadrilateral, yes. That's not quite a theorem, though.
But that is true. They do have 4 sides.
Any others, or do you need me to help you out?
4 congruent angles.
Not quite.
Opposite angles.
Opposite angles, yes, that's what we want there. Opposite angles will be congruent. And if you remember, opposite angles are kind of diagonal from each other. Diagonally across the parallelogram from each other. So we got opposite sides are congruent, opposite angles are congruent. There are 2 others. Yep.
Diagonals bisect each other.
There we go. Diagonals bisect each other. That's usually the hardest one to remember. And then we got one other. We didn't come up with this one last week. I'll help you out. Your consecutive interior angles. Oh, I think I spelled it wrong. Consecutive interior angles will be supplementary. So that right there, that's nothing new. That's just 6.2, a review of what we did. And I'm putting that up there because today with 6.3, a lot of those theorems we're going to do just kind of the converse of them. We're going to do it backwards. So let's sum up 6.3 for you real quickly. Now, in 6.3, we're going to do it backwards. So we said here in 6.2, we said if it's a parallelogram, then these things happen. In 6.3, we're going to say if these things happen, then it's a parallelogram. So we're going to do this just a little bit differently here. We're going to say this. If, and then there's going to be 4 things that happen. And if these 4 things happen, then the figure is a parallelogram. And you're going to find there's a lot of repeating from what we did in section 6.2. There's really just one new theorem you're going to get today. So let's start with the ones that we already know. We're going to start with the opposite sides, like we did in the first one here. This one, this term is going to say if the opposite sides are congruent, then it's a parallelogram. Second theorem is going to be just like the same exact order we did here. Opposite angles are congruent. If your opposite angles are congruent, then we can say it's a parallelogram. Maybe I should put a comma behind these, since this is how the sentence is finished off. And then the third one, lines up just like we did here. Diagonals bisect each other. If the diagonals bisect each other, then it's a parallelogram. So those are nothing new to you. Those are just converse theorems you had back in section 6.2. Here's the one new theorem. It's going to say if you have one pair of opposite sides, and that one pair of opposite sides is going to do two things. Your one pair of opposite sides is going to be both parallel and congruent. If that happens, then it's a parallelogram. So this is your one and only new theorem. So let's draw a picture of what that's going to look like. If you have a four-sided figure where you have a set of opposite sides, take the top and the bottom. They're both parallel and congruent, then that makes it a parallelogram. So here's section 6.3. Kind of put both sets of those theorems together. Here's the ones we know from 6.2. Here's the 6.3 ones with your one new theorem in there. One new theorem says if you can get a set of sides to be both parallel and congruent, then it's a parallelogram. All right, a couple things we're going to have you do with this. First one, they're going to give you a picture and they're going to have you determine if it's a parallelogram. So here's our directions. They're going to have us determine if the quadrilateral is a parallelogram. I'll do some abbreviating here. We use that symbol for parallelogram. And then they're also going to tell us to justify our answer. And then these are really pretty simple. They just give you a picture. You look at the picture and you determine if it's a parallelogram. So here's our first one. We're going to have a four-sided figure. We have our sides on here. We have a 12, a 5, a 12, and a 5. And then it's just a matter of looking at the picture and matching it up to your theorems to see if it matches up with any of our theorems. On this quadrilateral here, the top and the bottom are both 12. That makes them congruent. The left and the right-hand sides are both 5. That makes them congruent. We have the theorem that says if both pairs of opposite sides are congruent, then it's a parallelogram. So this one would be a parallelogram. So our answer is yes. And then we have to justify our reason. So basically, we just put into words what's happening here. Say both pairs of opposite sides are congruent. If you want to do some abbreviating on there, you can. But you will need that justifying part. You will have to explain why or why do is not a parallelogram. All right, let's try another on this one. This one, we're going to have a pair of opposite angles that are 85 degrees. And the top and the bottom are congruent to each other. Again, we just want to look at the figures, see if it matches up with any of our theorems. If it does, then it's a parallelogram. If it doesn't, then it's not a parallelogram. So I'm going to bring the theorems again. We have a set of sides that are congruent, and we have a set of opposite angles that are congruent. So as I go down my list, it says the opposite sides are congruent. We have one set of opposite sides congruent, but not both. So it doesn't justify that first theorem. Second theorem says opposite angles are congruent. We do have one set of opposite angles, but not both. So we don't have enough here to say that it's a parallelogram. Diagonals bisect each other. We don't even have diagonals drawn in here, so that one doesn't help. And then your fourth one, if you get one pair of opposite sides to be both parallel and congruent, we do have a set of sides congruent, but it's also not parallel. So on this one, we don't have any theorems that will justify saying this is a parallelogram, so our answer is no. And then when it comes to explaining this, you could word this a lot of different ways. I'm going to say something along the lines of just one pair of opposite angles congruent. Same thing with your pair of opposite sides. So as long as you're saying something along the lines of it doesn't have enough to make it a parallelogram, your justifying part will be good. All right, before I move on from this one, any questions with why this one's a no? Okay, let's give you one to try all by yourself. Here's the picture. You have to figure out if it's a parallelogram or not, and justify your answer. Try that one out and see how you do. That one there. We have some mixed answers out there, some yeses, some no's. Let's take a look at this one. All right, in order for it to be a parallelogram, it has to satisfy one of these four theorems. Both of your opposite sides are congruent. In this picture, we just have one set of opposite sides congruent, so that doesn't work. If your opposite angles are congruent, we don't have opposite angles congruent on this one, so that one doesn't work. Diagonals bisect each other, we don't have diagonals in here, so that one doesn't work. And your last chance is if you have one pair of opposite sides, both parallel and congruent. That does happen here. We have one set of sides that's both parallel and it's congruent. So our answer here would be yes. And for our justifying, say one pair of opposite sides. It's both parallel and congruent. Parallel and congruent. And again, if you want to do some abbreviating, that's fine. You don't have to word it exactly the way I do. As long as you're basically describing the same thing I am, you're going to be fine with that. All right, does anybody need to see some more like this? Okay, the last thing we have then, I think I'm going to start a new piece of paper just in case. Directions for this one are going to be almost the exact same thing. They're going to have us determine if the quadrilateral is a parallelogram. They're going to tell us to justify, but this time we're going to justify using what they call the slope method, or the slope formula. This is going to look new to you at first, but it's actually something you've already done this year. It's just going to tie together some stuff you've already done. All right, here's what they're going to do. They're going to give you the four corners of your quadrilateral. So we're going to say that point K is at 2, 3. Point L is at 8, 4. Point M is going to be at 7, negative 2. Point N is going to be at 1, negative 3. And then they're either going to give you some graph paper or you'll kind of freehand it on your own. This is for our notes here. We'll just freehand it. When you do this on the test or quiz, there will be graph paper for you. And here's what we're going to do with this. We're going to take these four coordinates, which are going to be the corners of our quadrilateral. We're going to put them on our graph, and then we're going to figure out by using slope if we have a parallelogram. So let's start by putting the points on here. Point K is at 2, 3, which takes me 2 to the right, up 3. Point L is at 8, 4, that takes us out 8, up 4. Point M is at 7, negative 2. That's going to take you 7 to the right and down 2. And point N is at 1, negative 3. That takes us 1 to the right, down 3. And then if I connect those 4 points, there's my quadrilateral. And then what I'm going to do, now that I've got my picture on here, I'm just going to go back and make sure these points we have on here. This is point K, which is at 2, 3. Point L is at 8, 4. Point M is at 7, negative 2. Point N is at 1, negative 3. That's the easy part. Now what we're going to do is figure out if it's a parallelogram by using slope. So just to take you back a little bit, over here on the right, we're going to do the slopes. And as a reminder, to find the slope we abbreviate with an M. We're going to subtract the y coordinates over the x coordinates. That goes back to first semester. Find slope, subtract the y's over the x's. Typically, your answer will be a fraction. Sometimes it comes out as a whole number, but usually it's going to be a fraction. And then if you remember back to first semester, we said that in order for lines to be parallel, they have to have the exact same slope. So we're trying to figure out if this is a parallelogram. Well, if it's a parallelogram, the top and the bottom have to be parallel, and the left and the right have to be parallel. That means those sets of sides have to have the exact same slope. So what I'm going to do is go down here and find the slopes of the following sides. Let's start with the top and the bottom. We'll start with KL. And now what we're going to do is just put in the slope formula. We're going to subtract the y's over the x's using points K and L. KL is the top side. So subtracting the y's on top, I can either go 3 minus 4 or 4 minus 3. It doesn't matter. I'm going to go 3 minus 4. The important thing is that whichever order you do it on top, you do the exact same order on the bottom. Since I went 3 minus 4 on top, I have to go 2 minus 8 on the bottom. If you went 4 minus 3 on top, you'd have to go 8 minus 2 on the bottom. Then we can simplify it. 3 minus 4 is negative 1. 2 minus 8 is negative 6. When you have a negative over a negative, those become positive. Our slope of KL is going to be 1/6. So it's a fraction. Yeah, like I said, most of them will be. Now on the bottom side, in order for this to be a parallelogram, the top and the bottom have to be parallel. They have to have the exact same slope. So let's do NM and see if they have the same slope. Now we're going to do the same thing with the slope for the bottom 2 points. So we're going to subtract the y's on top. I'm going to go negative 3 minus negative 2. Y coordinates always go on top. Then the x coordinates on the bottom have to be 1 minus 7. And our double negative becomes positive. Negative 3 plus 2 is negative 1. 1 minus 7 is negative 6. Once again, negative over negative becomes positive. These two do have the exact same slope. Since they have the exact same slope, that tells us they're parallel. So we're halfway there. We know the top and the bottom sides do have the exact same slope. So they're going to be parallel to each other. Now we have to see if the left and the right-hand sides have the same slope. So let's start with the left-hand side, KN. And we'll just go through the exact same process with KN. Subtract the y's over the x's to get the slope. This one, you either go 3 minus negative 3, or you could go negative 3 minus 3. Either way is fine. Since I went 3 minus negative 3, I went from the top to the bottom. We got to do the same thing for the x coordinates. Top to the bottom would be 2 minus 1. We have a double negative here again, so 3 plus 3 is 6. 2 minus 1 is 1. 6 over 1, you can leave it as a fraction or you can change it to 6. Either way is fine, doesn't matter. Now, the last thing I need to do is I just did KN, now I got to do LM. If LM has a slope of 6 over 1, then those lines are parallel. So let's see if it does. And again, we'll do the slope formula of y's over the x's. I'm 4 minus negative 2 for the y's. 8 minus 7 for the x's. Double negative becomes positive. 4 plus 2 is 6. 8 minus 7 is 1. These two lines do have the exact same slope. That's going to make them parallel. So we've shown that both sets of opposite sides are parallel to each other. So going back to answer their question, is it a parallelogram? The answer would be yes. There's our first answer. The justifying is we just showed that both sets of opposite sides are parallel. Again, you can abbreviate on that if you want to. There's the answer. So if this was a test question, this would probably be worth 3 points. You'd get 1 point for the yes or the no. You'd get 1 point for showing all the slopes, and you'd get 1 point for your explanation. Just fine. So you kind of need all of those parts to show that this is quadrilateral or it's not quadrilateral. Or it's not parallelogram. All right, kind of a lot of work. The good thing is it's not really difficult work. Does anybody need to see another one of these? No? Okay. Then I believe that's all I need to show you. Yes. So today is in the packet of stuff we gave you. You should have a worksheet that looks like this. Got two sides to it. And if you're here in class today, as soon as you finish that, you can bring it back with any other stuff you have. We'll get those put in the grade book today. Those of you at home, when you finish this, just bring it with you to class tomorrow. We'll put it in the grade book tomorrow.